Pirate radio. So in this case, pirate, you can transmit. Now this one you might find interesting. There's the link. You can turn your Raspberry Pi into an FM transmitter using GPIO number 4. And that's showing this red wire coming off of GPIO number 4 as its antenna. Although very limited in range, this project demonstrates how to use Raspberry Pi for radio transmissions without a transmitter. So what they're doing is, earlier when I said you could program frequencies through software to come out of a GPIO pin, what they're doing is they're using it to modulate that particular GPIO pin by changing the frequency. And because it's pirate radio, you can have audio go into it or play a signal, and it's going to be modulated out through this pin. How far does 3.3 volts DC go when you modulate it on and off? Not very far, but the next one might explain a little different here. So the next one is a whisper transmitter, because you can modulate that GPIO pin 4. What this particular organization did, Tucson Amateur Packet Radio, and there's their link, they decided to take that, modulating that pin a step further by building a whisper transmitter, and they call it Whisper Without Tears, and that's that board that is on there, and they make a couple of different boards, and it's still based on Joe Taylor's Whisper mode. So what this particular board is doing is it's filtering the dirty digital signal that you would get out of the GPIO pin and cleaning it up so that it's an analog modulated signal when it leaves the BNC connector here to your antenna. Okay, there's another link here that I've put there, and they're claiming to accomplish the same thing without using additional add-on boards, using Raspberry Pi, and it uses bare boards Raspberry Pi to build low power transmitter, CW transmitter from 0 to 250 megahertz. You can build a satellite tracker. Okay, build a satellite tracking station to aim your antenna. So this one will this is a project that gives you instructions how to build an antenna that's going to follow the satellite while you're talking on it. In this case, they use a Mac computer running Mac Doppler, so it may not be suitable for everybody with the way the project sits. Doesn't mean it can't be turned into a project that's strictly Raspberry Pi. It just means that this particular project is set up for a Mac with a Raspberry Pi. Okay, you can build a weather station. If you want to build your own from scratch, this tells you how to do it. And it allows it to be accessible by a web page that it creates. So you would have it connected to your network at home, and you can just go on network to access the Raspberry Pi, and it'll give you a browser page with the information that you populated it with about your weather. Next one is automated weather satellite ground station, and it allows you to use Raspberry Pi in an RTL SDR dongle to build an automated ground station to receive and decode NOAA weather satellite images. Okay, so you can look at their maps that they download. Okay, this one's R2 Cloud. Very similar, but you can do a little bit more with it. configure Raspberry Pi with R2 Cloud to track and decode various radio signals from satellites, such as weather satellites and APT and LRPT. So there's different weather satellites up there. I believe one of them is a Russian network and the other is North American. You can do CubeSats and the different digital modes and more. So I'm not sure everything else that it can do more, but it is supposed to be pretty good. You want to do slow scan TV, so it'll capture the image if you have a camera. If not, you can transfer an image to the Raspberry Pi for transmission. It then converts that picture into a sound file using Pi SSTV software, free, and the links there where to get everything. Transmit the sound file with Pi FM, and it's transmitting it on GPIO 4. That just seems to be the default pin that they like using for it. You can take and send an image on detected motion. So if you had a camera set up with a motion and you wanted it to, say your ham shack was in your backyard and you wanted it to alert you, if it detects motion, it'll send you an image to your house. If you wanted to, it doesn't have to be across radio. Or you could have it across like a 433 megahertz low power module that they make for the Raspberry Pis, or a LoRa module, things like that. It'll also add your call sign to the transmission. Okay, so the links are here. So because if you're transmitting it with higher powers where you need license, that's when you need to include your call sign. This was just an idea that I seen out there that people might be interested, because there's people with drones. They're saying you can turn it into a drone repeater. I don't see it being a in-band repeater because of the filter networks involved, but as a cross-band repeater, you can do that fairly lightweight with a handheld. Next one is MIDI satellite antenna rotator. So this one here will track your satellite and tells you everything you need to do to do it. They're showing an iPhone or an Android, I think it's iPhone, with it. Just so then you know just what it's pointing at. It's only informational. It's not for communicating and things like that. It's just to know what satellite it's pointing at and what angles it's pointing. SARCnet itself, I found was an interesting site, so I decided to state that. There's a lot of other amateur radio projects that you can build, just not necessarily Raspberry Pi. It could be maybe an ESP32 or Android, not Android, but I can't think of the other one right now. You know the one I mean. The other microcontrollers out there. You can build a Morse code transmitter. Okay. In this project, they're using just light emitting diode to visualize Morse code being transmitted, but you could easily adapt it to Kia radio instead of turn the light on and off. Hotspots, that's common. Okay. I showed different hotspots here. You can get them in a kit form. You can get them pre-built. Anyway, we covered in another project as well, or another presentation. You can use your Raspberry Pi to build an all-star radio interface. So here's a couple of parts that you could buy. You could buy it off of Amazon. This is the one I found on Amazon. It uses the two USBs spaced. You have to make sure you get the one that's spaced for the spacing of the USB ports for the particular Raspberry Pi you have, and the 4 is slightly different than the 3. or use cable extenders between them so you don't have to worry about spacing. I believe this one's the clone of the Shari that's below it. And this is, you have to go to the particular site, Ham Projects Info Shari. You can buy it in a kit form. You can buy it built. You can also buy it as a hat. And this is the hat version, where it just plugs directly on the board. This version in the kit form plugs into the 2 USB ports like the Amazon version. Okay, you'd also, if you are buying a board, you need to specify which band you want, because they're band specific, 70 centimeter band or 2 meter band. So that would allow you to have all-star access from your radio. Ham lib. Oh, question. Okay, 73 Marie. Ham lib. There's a site there. Basically, you download my recommendation is you download the entire file and burn it to your, or write it to your micro SD, because it's one of the amateur radio operators out there went through all the trouble of tracking down a whole bunch of different applications that he liked, that allows you to do a lot of things. And loaded it up. Oh, sorry, I'm one step ahead of myself. This one's a Ham Radio Control Library. It's an API, meaning it's just this blue stuff in the middle, and it allows you, if you're a programmer, to use your own app, interface to a standard, and then the standard already knows how to talk to all these radios. So you only have to know how to talk to one thing, not all these different radios. So even if you're not a programmer, there's user apps out there that use HamLib. So if it calls for HamLib, this tells you how to get HamLib, and it already knows how to talk to all these different radios out there. Okay. GP Predict. It's real-time satellite tracking. I know that you get that with Ham Clock. However, this one will do multi-satellites. You get them in there, and it'll track the simultaneous multi-satellites, okay? And it will do it on a map, in tables, or a list of information. It can also Doppler tune radios using HamLib, which was on the previous page. And it can also control your antenna rotor control so that it's pointing at the antenna or at the satellite as it's passing, the one that you want to communicate with. HamPi, that's the one I started explaining earlier. Okay, it was formerly called Raspberry Pi for Ham. It's a collection of pre-installed amateur radio applications. The image file is the only thing that needs to be loaded. So the amateur, one of the other amateur radio guys out there, in this case, W3DJS, he went out there, found a bunch of applications, put them on a Raspberry Pi, made them work. So they're already pre-configured up and running. There shouldn't be anything really that's required to do if your Raspberry Pi is configured to access the internet and things. Okay. I gave the different links where to get them. If you want a list of the complete list, because it literally is tons of stuff in there, that's the link to what's on the image, the current image. There's an alternate to this called, instead of called HamPi, it's called Ham-Pi. Okay, so HamPi as well. Very, very similar. It's a matter of preference. Okay, what do you get from it? You get general applications such as Chirp, QTEL for Echolink, ADS-B, which is aircraft. and VOCAP HF propagation predict. Antenna applications for design and analyze. Digital mode applications, if you're using digital modes using a Raspberry Pi, here you go. SDR, if you want to use SDRs on your Raspberry Pi, there's a few there, and it's covering the RTL SDR, which is the most common dongle. And then if you have a SDR player or HackRF, then there's apps there for that too. APRS, FLDigi, logging applications. I think most people already have their logging software, but they include them here as well. WebLink, if you want to do radio email. Morse code applications such as rig control, training, conversion. Okay, bye, Pat. Digital mode repeater. Okay, it's showing older radios here, older digital radios that have a digital port on the back. And it's showing you how to do this using the Raspberry Pi and build a MMDVM repeater using Raspberry Pi. Okay, I went into operating system because it was just short, and if anybody was setting up their own Raspberry Pi, that's why I covered this part. Raspberry Pi OS is 32-bit is the most common one out there that's in use, with a desktop, meaning it's looks like similar to Windows. You get a visual graphical user interface. Okay, it's the most popular operating system. With the exception of the Pico, all Raspberry Pis are compatible with this operating system. Pico doesn't use an operating system. Raspberry Pi OS Lite, 32-bit. It's the same as the OS, but it's a minimum install and has no GUI, no graphical interface. So if you don't mind there not being a GUI, then you can load that one. There's also a 64-bit out there because Raspberry Pi is 64-bit. Raspberry Pi OS, 64-bit with desktop, is compatible with 3B, 3B, 4, 4, and 02W. The other ones, it's not. It is not as popular as the 32-bit because I think they've just started with the 4B, spending more time on the 64-bit. Okay. Another operating system, LibreELEC. You like Kodi Entertainment Center, then this is the one for you. LibreELEC or OpenELEC and OSMC are all other Kodi type operating systems. They have apps that will go out on the internet and play video files off the internet. If you have a Amazon Fire Stick, same thing, using a Raspberry Pi, where the Fire Stick is more specific for Amazon Prime, but it does have access to a lot of these other Kodi things off your Raspberry or off your Fire Stick. This is just using a Raspberry Pi. Ubuntu. So if you are already using Ubuntu on another computer and you like it, it's another form of Linux. You go to the Ubuntu site and you download Raspberry Pi for Ubuntu. RetroPie, turn your RetroPie into a gaming machine. There's also other emulators out there. It includes Recalbox, Laka, and Pi Entertainment System. There's literally hundreds of games out there so that you can play your old Pac-Man game, any of those old ColecoVision and those types of games that Atari, you go into an arcade, all those games are out there for downloading. You put them through a RetroPie, for example, and it'll let you play it now on your you know, Pac-Man on your big screen TV. There's also a lot of PlayStation 1, 2, and 3 games out there. They're much bigger file sizes. They do work. So if anybody is interested in that, it's on the internet for people to be able to do that. It will even let you interface your Xbox or PlayStation game controller to the Raspberry Pi so that you have the same control so that you would if you had the game in front of you on a PlayStation. RISC OS is for anyone interested in specifically using the operating system designed for ARM processors at the more at the machine level, not the English level where you can type commands in. Okay. Take care, Ted. Okay, Kali Linux used for network penetration testing. So if you're into network penetration testing to find out where vulnerabilities are, Kali is the one you want, okay? Motion Eyes OS, if you want to use it specifically for a security system, this would be the one you want. I'm not sure if I'm pronouncing this right, but Ichigojam Basic, if you learned BASIC earlier and you liked basic programming language, this is the one you want. It supports digital I/O, pulse width modulation, I2C, and UART functions. So that's nice within BASIC. Here's a big one that is controversial. Can you run Windows? So Windows 10 Internet of Things, IoT, Core OS, okay? I believe that one is a Microsoft product, but it's used primarily for Internet of Things development. Has no graphical user interface. For best results, you need to remotely connect into it from another computer. Okay? So Internet of Things was designed so that you could control things over the internet. No GUI. So take it or leave it sort of thing. So now we go on to, well, Windows 11 is out now. So Windows 11 for the Raspberry Pi is a third-party operating system, not an official Microsoft product. Okay. It supposedly works well with non-demanding applications. Well, everything we run nowadays is demanding. So the other bad thing is there is no GPIO header support. So, yeah, you can run a version of Windows 11 third party, but you can't do anything that we might want to do with it that uses any of the sensor pins, GPIO pins. Okay, there's many other operating systems out there. Okay, so for those that are new to Raspberry Pi, I put on here how to load it, and the presentation is almost done for those that are wondering. Okay. One of the easiest ways to install the operating system on a Raspberry Pi is by restoring a previously created image. This is the way 99% of the people out there do it. Okay, why? Because it's pretty painful doing it from fresh. Okay, so Raspberry Pi, as well as other developers, created a number of operating system images, as I just went through 2 pages of them, making them available for download and free to use. Good price. Okay. Raspberry Pi has also provided us with free software to restore the image file, known as Raspberry Pi Imager. The Imager tool is a tool that facilitates writing Raspberry Pi image files to a micro SD card, provides easy access to some of the most common images, including images previously saved to your computer. It's available for Windows, Mac, Ubuntu, and Raspberry Pi. Okay, we'll see you later, Igor. If you don't already have Raspberry Pi Imager on your computer, download it and install it from this link. It's hardly anything on that page. It downloads easy by following the link, and it runs easy. So if you get stuck, feel free to ask questions if you're at that point where you want to install it. But it is fairly easy, but I still can answer some questions if you have. Okay, how to install the operating system. So we're assuming you got Raspberry Pi Imager installed, okay? So insert the micro SD card into your computer, run Raspberry Pi Imager. If you get those two in a different order, it'll still work. Choose the operating system you want to install. It's a drop-down menu, okay? Confirm it's compatible with the Raspberry Pi you want to run it on. Optional is to pre-configure OS. When you are in the installer, you can press Control-Shift-X, and it'll give you a chance to make settings that you would normally get on first boot. I'm not sure. I think they did that for where they're going next in their installation. But for normal install, I usually skip this step if I'm using the Imager on my Windows computer. Okay. So you put the SD card in, you choose your operating system. Next, you choose the storage location, and it should only have the one loaded. It won't pick your hard drive and put it on the list. It usually only lists your SD card that you have, or properly worded micro SD card, okay? Then you click Write and verify the image. At this point, the SD card's ready to be inserted into the Raspberry Pi. So when it completes this image, the Raspberry Pis can be unplugged from the computer and plugged into the Raspberry Pi. Procedure is the same for all Raspberry Pis. As long as you picked an operating system that was compatible with your Raspberry Pi, the procedure's all the same, okay? When you first plug it in, further configuration of the OS will take place on first boot, okay? Once it's done first boot, or while it's doing it, it's going to ask you, so what's your time zone? What do you want to keep the username and password that it has? I recommend keeping it until you're completely set up, because it's just easier. Because if you're picking a different username and password for a different configuration and you forget it, I find it easier to just use the default. Okay, it'll ask you for your network setting, things like that. When it's all done and up and running, I recommend the next step to go into Terminal. It's on your Raspberry Pi menu. It opens up like a DOS window, but they call it Terminal. And you go in there and you type these lines to update your Pi, because it might have missed some updates, okay? So you type the word sudo space apt space update. So it's gonna upgrade, it's gonna update any files it needs to update. Raspberry Pi separates updates from upgrades, okay? So it might have had a string of version 2.1.3, so that's version 2, and it might update all of the version 2s, but let's say it went up to a 3 now, okay? That's where the upgrades will catch it, okay? Is anything that's more than a minor update. If it's a more serious, that it's a version upgrade, then it'll catch them then. So anytime you run an update, I highly recommend you run upgrade, okay? The reason you need sudo is because it wants, that command tells the Raspberry Pi that you're locked out from most of the commands that are meant for the administrator. So if you don't put sudo in front of it, it's going to lock you out. If you put the word sudo in front of it, so let's just say, for example, you ran update. All it's going to do is say it's going to come back that it failed, okay? So you put sudo in there saying, I know I'm the administrator and I want to run this command. So normally you don't put sudo there unless it takes admin rights. In this case, an upgrade and an update require admin rights, so you put the word sudo in front of it, just to let you know. Okay, so that gets your Raspberry Pi totally up and running, just no apps installed. So if that at that point you wanted to try one of those other things to run that we talked about earlier, you could go there and start configuring it to run those. So it would get you up on the internet just as a Raspberry Pi. This is required for almost everything you do. Okay. So anyway, what to expect when you buy a Raspberry Pi? Expect that it's a bare board, just as you see there. It's got the connections on it. It may not have the header pins on the zeros. If you're buying a kit, it may not have all the pieces you need in the kit. Some kits don't include the board itself. Other kits may not provide these little dongles that you might need. Anyway, just be aware of what's in the kit. And some kits provide you with more than what you need. In this case, what's more than what you need? Raspberry Pi says if you're running the Raspberry Pi normally, okay, in a normal mode, you don't need the heat sinks, you don't need the fan. Having said that, people learn that you can overclock a Raspberry Pi. So it's no longer in normal mode, so you may need the fan, you may need the heat sinks, okay? You can see that this particular kit has a adapter to adapt to plugging in the normal USB port. The other kit doesn't. Okay, take care, Ted. The kits may not have a case that's desirable for your project. So when you buy kits, consider what they come with, what they don't come with, okay? To make sure it meets your needs. Okay, they're typically sold as a bare board. They can all operate in headless mode, but you'll still need a micro SD card, power supply, protective case at minimum, even if it's in headless mode, meaning you're not using anything plugged on to the GPIO. To operate it like a desktop computer, you need a monitor, keyboard, mouse added to it. Optionally, Raspberry Pis can be purchased in kits. Still need a monitor, keyboard, mouse. Monitor, you can also use your big screen because it's HDMI. Okay. Kits sometimes include heat sinks, fans, covered that. Caution, some kits don't include Raspberry Pi. Okay. Some sell at twice the price. And so I gave examples of where you can get them in Canada. Pi Shop, they're in Ottawa. There's their typical prices for the different versions I've talked about. I put an 8 gig and a 1 gig on there, so you see the difference in price. The 3B, the wireless 2.0 and the 0 with header and without a header. So you're looking at $7 more, or even without a wireless, okay? So if you get it without wireless, you're saving again. But if you want wireless, then you need to get that. And the price of a Pico. Okay, the price of a Pico for what it can do is very inexpensive. Canakit, they're out in BC. Prices generally follow exactly the same as Pi Shop, and they're pretty much what Raspberry Pi has set, okay? I didn't see a 3B on their site. I did see zeros, not the zero wireless, but the wire, the ones that are wireless, should say, not the wired one. Okay. Pico, same price again. Canada Robotics is Toronto. The only one I found on their site was a 4B, 8 gig, and a Pico. I put them in there because maybe sometimes they do have pages that they have the others. They also did have a lot of sensors on their site for reasonable prices. Amazon.ca. I've bought from Amazon.ca. The CanaKits are sometimes on Amazon. When they are, they're generally the same price as CanaKits from CanaKit. Okay. When they're not available, their prices go 3 times of what they're worth. Okay, take care, Bill. Yeah. So out of these, none of them had them in stock, except Amazon. When I checked a couple of weeks ago, at 3 times the price, yeah, I don't think so. That's gouging people, and it's not Amazon selling them. It's a third party using Amazon as a website to host their sale. Yeah, Tom, when I checked their site, they were still out of stock. Stock is a problem. And one of the reasons I heard that stock is a problem is because one of the factories involved at one of the pieces that populates these boards had a fire. So hopefully that's all fixed soon. They do have 3 different places. They say that they assemble the boards, and it's I think it's 2 places in the UK and 1 place in China, but the majority, I believe, get built in the UK. So yeah, parts are getting the boards is a problem, but when even though there's a shortage, if PiShop or CanaKit happen to get their hands on them, I can almost guarantee you that they're going to sell them at the Raspberry Pi recommended prices, because they are determined that they want the board to be readily available, or well, readily is not really there right now, but they want their prices to remain inexpensive. If you start putting these prices up higher, then what's going to happen is no one will be able to afford them. If they have to afford the more expensive price, they're just going to buy a PC. Okay. So Amazon is still a good place if Amazon is selling it themselves, shipping it themselves as a CanaKit product. I haven't seen any PiShop products there, but I have seen CanaKits there. And CanaKit is the seller, and Amazon is the shipper. Okay, they tend to be the same price that they would be anywhere else. When they're a third party, meaning not sold by Amazon, not shipped by Amazon, they seem to really inflate. And that's people that got their hands on one and said, I'm going to take advantage of people and I want 3 times the price. If you're desperate, you pay it, and if not, then you wait. Okay. They are still a good source of all the sensors that you can find. A lot of times you can get them there for a reasonable price, similar to eBay prices if you're waiting the 2 months to get it out of China. And sometimes you're waiting the 2 months to get it out of China for Amazon as well. Okay, I put the links to each of those places with a little description and the warning for if you're getting off Amazon. Okay, references I used for putting the presentation together, good references for digging out more information there are on the top half. Useful links and why. Okay, the first one, excellent link, is an interactive resource detailing Raspberry Pi GPIO pins. So if you open up that link and you go to that link and you click on a pin, it gives you information about that pin. If you click on, for example, I2C, it gives you information about what I2C is, and what pins are applicable to it. It's a very good resource for getting the information on a click of a button sort of thing. Okay, you want information about hats and add-on boards, GitHub Raspberry Pi hats is a good spot. And when it gives you that information, there's information there that's going to tell you what it has to have in order to be classed as a hat. Okay, Pi My Life Up. It's also good information about GPIO pins. Electronicwings.com is good for pulse width modulation. RaspberryPi.org apps. It has that particular link. It talks about all the alternative function assignments for Raspberry Pis. Okay, if you just like listening, if you like information about, like to listen to information about it, the Raspberry Pis, there's Echolink and All-Star links about Raspberry Pi Net. It's run by a guy, John, W2JLD. He's in Rochester, which is within reach of here from my location, because I'm in Trenton, just the opposite side of Lake Ontario. But they also are on EchoStar and All-Star. So if you go to that link, it'll give you the EchoStar and All-Star links if you want to listen to Raspberry Pi Net. They are every Sunday afternoon, if I'm not mistaken. Okay, if you like tons of good information about Raspberry Pis with respect to an amateur radio operator, this particular guy, N6RDF Mike, he nicknames himself Frankenpie. If you go on QRZ and then search his call sign, his QRZ page goes on forever. There's a lot of good information in there, not just with respect to amateur radio, but he goes on forever on his QRZ page, and it literally goes on forever. You know you got the right guy if it comes up as Frankenpie when you scroll down his page.